Hello everybody, getting ready to do lesson 4.3 part 2 today of pre-calculus math. This is my email if you need materials or tutoring, note-taking guides, etc. 4.3 part 2, and today we got a 44-point classwork sheet to do, and you have 4 points to put into your notebook, students, so be prepared for that. Page 1 on part 2, sines, cosines, and tangents of special angles. So sine 30 equals a sine of pi over 6, which equals 1 over 2 as a function value for that. Then cosine 30 equals cosine pi over 6. Pi over 6 is the radian measure for 30 degrees, and that is square root of 3 over 2. And then tan 30, tan pi over 6, will be a square root of 3 over 3. Then sine 45 is the sine pi over 4, is your radian measure for 45 degrees. And that's square root of 2 over 2. And then cosine 45 is square root of 2 over 2. And then tan 45, which is pi over 4, y over x, is 1. And for sine 60 degrees, which is sine pi over 3, is your radian value for 60 degrees, it would be square root of 3 over 2. Cosine 60 would be 1/2, and then tan 60 would be square root of 3. In the box, note that sine 30 degrees equals 1/2 equals cosine 60 degrees. This occurs because 30 degrees and 60 degrees are complementary angles. And in general, it can be shown from the right triangle definitions that cofunctions of complementary angles are equal. Isn't that interesting? That is, if theta is an acute angle, then the following relationships are true. Sine 90 degrees minus theta equals cosine theta. And then cosine of 90 degrees minus theta equals sine theta. And then tan of 90 degrees minus theta equals cotan theta. And then cotan 90 degrees minus theta equals tan theta. Secant 90 degrees minus theta equals cosecant theta. And then cosecant 90 degrees minus theta equals secant theta. To use a calculator to evaluate trigonometric functions of angles measured in degrees, set the calculator to degree mode and then proceed. Okay, page number 3, part 2, using a calculator. Use a calculator to evaluate cosine 5 degrees, 40 minutes, and 12 seconds. So begin by converting to decimal degree form. So 5 degrees, 40 minutes, and 12 seconds equals 5 degrees plus 40 over 60 degrees plus 12 over 3600 degrees equals 5.67 degrees. So when you combine these, or rather when you convert these to degrees, this is minutes, there's 60 minutes to an hour, and then to an hour here, how many seconds there are to an hour is 3,600 seconds to an hour. So that's how you go from 40 over 60, and then for 12 seconds is 12 over 3,600 degrees. And that comes out to, when you do your calculator crunching, that comes to 5.67 degrees. Then use the calculator in degree mode to evaluate cosine 5.67 degrees. So when you do that, you go on your calculator, cosine 5 degrees, 40 minutes, 12 seconds equals cosine 5.67 degrees. On your calculator, cosine 5.67, enter, and that will equal right here for your function value of cosine 5.67 degrees. Okay, let's try one now in our guided practice. use a calculator to evaluate this function here. Round your answers to 4 decimal places. Students, this is yours down here. We're going to do this one up here, 33a. So secant 42.2 degrees would equal 42 degrees and 12 minutes is the same thing as 0.2 degrees here, 12 minutes. So that would equal secant 42.2 degrees would equal 1 over cosine 42.2 degrees, which equals 1.3499 as a function value of this function here of secant. And then down here, I go ahead and do this for you. Sine, the cofunction for cosecant is sine. So 1 over 48 plus 7 over 60. This is 7 minutes here. 7 over 60 degrees equals 1.3432 as a function value of cosecant for this value here. Fundamental trigonometric identities. Reciprocal identities. Sine is 1 over cosecant. Cosecant is 1 over sine. Cosine is 1 over secant. And then secant is 1 over cosine. These are inverses of each other. And then tan is 1 over cotan. And then cotan is 1 over tan. This will go in your notebook, students. So write these down in your notebook where I do my notebook checks on Fridays usually. And another notebook entry here, quotient identities. So tan theta would equal sine theta over cosine theta. Cotan would equal cosine over sine. And then Pythagorean identities, sine squared theta plus cosine squared theta equals 1. 1 plus tan squared theta equals secant squared theta. And then 1 plus cotan squared theta would equal cosecant squared theta. Note that sine squared theta represents sine theta squared, and cosine squared theta represents cosine theta squared. Okay, let's go into another example here. Example 5, applying trigonometric identities. Let theta be an acute angle such that cosine theta equals 0.8. Find the values of A, sine theta, and B, tan theta using trigonometric identities. So, to find a value of sine theta here, use a Pythagorean identity. So we plug in here, and we know our cosine theta here. So cosine, sine squared theta plus cosine squared theta equals 1. So you have, in this case, we can plug in here for cosine. Cosine up here is 0.8. We plug in 0.8. Sine squared theta plus 0.8 squared equals 1. Now we can solve for sine squared theta. This equals 1 minus 0.8 squared. We subtract 0.8 from both sides. And then sine squared theta equals 0.36. And then we're going to solve now for sine. So we take the square root of both sides. And so now we have sine theta equals 0.6. Now, knowing the sine and cosine of theta, you can find a tangent of theta to be tan theta equals sine theta over cosine theta. 0.6 over 0.8 would equal 0.75. Use the definitions of sine and tan theta and the triangle shown. So now our triangle will look like this. 0.8 for one side here, our adjacent side, and our opposite side here would be 0.6. Then our hypotenuse is 1. Okay, so in this situation here, use the given function values. So we have a function value of cosecant theta equals 3, and then secant theta equals 3 times square root 2 over 4 to find the indicated trigonometric function. So we need to find sine theta tan theta, cosine theta, and then secant of 90 degrees minus theta. So, and then down here, students, this is yours. You can pretty much do the same thing. So let's go into number 9 here. So A, sine theta, will be 1 over cosecant, and cosecant is here, so it'll be 1/3. And then our cosine theta will be 1 over secant. So what is our secant? Secant will be this here, so it'll be 1 over this quantity here. And then when you do your arithmetic, when you rationalize and everything else, you come to 2 times square root of 2 over 3. If you want this worked out, students, come see me. And then number for C here, tan theta equals sine theta over cosine theta. So that's our tan theta. So our sine and cosine, we have these up here. So it'll be 1/3 over 2 times square root of 2 over 3. And that hashes out to be in the square root of 2 over 4. And then secant of 90 degrees minus theta, so it would be cosecant. Here, your cofunction for secant would be cosecant. And the cosecant would be the inverse of 1 over 3, which would equal 3 here. Do I do this one? I do this one for you. So students, there it is. I'm not going to spend time on it. I want you to either go back into the video to get it, go to PowerShow to get it, or something like that. Okay, let's continue on. Apply example 6, applying trigonometric identities. Let theta be an acute angle such that tan theta equals 3. Find the values of A, cotan theta, and B using secant theta using trigonometric identities. So we have cotan theta equals 1 over tan theta, reciprocal identity. So here is our tan theta equals 3. So cotan equals 1 over 3. And so secant theta here, what's our secant? Secant theta, if we know our tan equals 3, we know our cotan equals 1 over 3. And we're going to use that Pythagorean identity. We're not going to actually go into, we could find it by using these ratios here of these functions, but we're going to use a Pythagorean identity method here. So secant squared theta equals 1 plus tan squared theta. So secant squared theta equals 1 plus 3 squared. We know that our tan theta here is 3. And then we're going to solve now for secant squared theta. So to do that, secant squared theta equals 10. So we're going to take square root of both sides. Secant theta equals the square root of 10. So here's our triangle here, 1, 3, and then square root of 10 for our triangle. Let's go into a guided practice now. We have given function values here. Cosine alpha, in this case, is 1 over 3. And then down here, tan beta equals 5. But up here, we're going to concentrate on this. Students, I'm going to let you do this. We're going to do this now. We know our cosine beta alpha is 1 over 3. So by knowing what our cosine is, our secant is 1 over cosine. So what we do here, we just flip this up, and that will be our secant value will be the inverse of cosine. And then we're going to use Pythagorean identity here for our sine alpha. We know our cosine alpha here is 1 over 3. Cosine is 1 over 3. We're trying to solve now for our sine squared alpha equals 1. So what we do now is our 1 over 3 squared is 1 over 9. We move that over to this side over here. And 1 is 9 over 9. So sine squared alpha equals now 8 over 9. Take square root of both sides. And then this hashes out to being 2 times square root 2 over 3 for sine alpha. And then for cotan, cotan is cosine over sine alpha. So we know our values for these two functions, 1/3 over 2 times square root 2 over 3. And when we hash this out, we rationalize the denominator, we come to a square root 2 over 4. And then sine of 90 degrees minus alpha is the cofunction of sine, which is cosine alpha, equals 1/3. I mean, we could solve that. We could go directly to this and solve that. And then down here, again, students, I'm going to let you go to either YouTube or to PowerShell to check yourself on that. But I want you to solve your own, if you can. Page 13 in our classwork. Using trigonometric identities, use trig identities to transfer one side of the equation into the other. Between values here, between theta is between 0 and pi over 2, which is your 90-degree position on your unit circle. So cosine theta secant theta equals 1. So simplify the expression on the left side of the equation until you obtain the right side. So in this situation here, cosine theta and secant theta equals 1 over secant theta times secant. So cosine is 1 over secant. So when we do that, we have a reciprocal identity here. These cancel. So this is actually equal to 1. A is actually equal to 1. Divide out your common factor, and you get 1 for that. And then B, secant theta plus tan theta times secant theta minus tan theta equals 1. So how do we get that to equal 1? How do we get this to equal 1 is the question. So secant squared theta, when we FOIL this out here and then over there, secant squared theta minus secant squared theta minus secant tan theta plus secant theta tan theta minus tan squared theta. So these two will cancel each other out after you FOIL this. And you end up with secant squared theta minus tan squared theta, which from Pythagorean identity we know this equals 1. So 1 equals 1. So it's a valid expression here. Let's go into an example, guided practice here. Use the trigonometric identities to transfer from one side of the equation to the other between our values here of 0 to pi over 2. And we have sine theta over cosine theta plus cosine theta over sine theta equals cosecant secant theta. So how are we going to prove that these equal each other? And down here, this is your students, so I'll let you do that. So our guided practice says sine squared theta plus cosine squared theta equals sine theta cosine theta. So what we do here, this is our common denominator for this side of our expression over here. And then we get this up here, which is equal to 1 by using a Pythagorean identity. This equals 1 over sine theta cosine theta. And then when we separate our denominator here, 1 times 1 over sine theta times 1 over cosine theta, that actually does equal cosecant theta secant theta. This is secant theta, and then this is cosecant theta here. Same expression. It's an equal expression as this. And I'll let you do that, students. Do that on your own. And that is your 4.3 part 2. So any questions, email me here. If you need materials, email me here. Thank you very much.